Graphene oxide, GO, nanomembranes remove heavy metal ions from water primarily through adsorption, a process where the ions stick to the surface of the GO sheets. The high effectiveness of GO is due to its unique structure and chemical properties. Adsorption mechanism. Large surface area. Graphene oxide has a massive specific surface area, providing a large number of active sites for heavy metal ions to bind. This 2D, sheet-like structure maximizes the contact between the membrane and the contaminated water. Oxygen-containing functional groups. The surface of graphene oxide is rich in oxygen-containing groups like carboxyl, hydroxyl, and epoxy groups. These groups are key to the removal process because they are highly hydrophilic and negatively charged. Electrostatic attraction. Heavy metal ions, such as lead and cadmium, are positively charged cations. These cations are strongly attracted to the negatively charged oxygen functional groups on the GO surface, leading to their adsorption. The pH of the solution is a critical factor, as it affects the charge of both the heavy metal ions and the GO surface. Complexation. The oxygen-containing groups can also form chemical bonds with the heavy metal ions, a process known as chelation or surface complexation. This strong chemical interaction further enhances the removal efficiency, making the binding more stable. Size exclusion. Graphene oxide nanomembranes are also used in filtration systems. The layered structure of the GO sheets creates tiny, nano-sized channels that allow water molecules to pass through while physically blocking larger heavy metal ions and other contaminants.